started? Where are we? Here's your official schedule. It's on course information. You know if anything changes, like a snow day or something. If we have like a second snow day, those are one of those things where I might still post the video lecture from last semester as if we're having class and not even take the snow day. Just to give you a heads up. The first snow day, we scheduled in a snow day. If you notice at the bottom of the schedule it says snow day, meaning everything's going to kind of shift down when we get that snow day. But last winter we had 3 snow days, you know, and 2 of them were on a Monday or Wednesday, and we were short, like one class was short 2 lectures compared to the other class, so it was really weird. So anyway, just bringing that to your attention. I always put the topics. The reason that these are posted, here's chapter 13, here's chapter 10, is because there's questions on all the quizzes and there's questions on the final that are problems, and then there's some multiple choice and true and falses. The multiple choice and true and falses could be over any part of the chapter that you're supposed to be reading on your own time, and I know you don't, but you should. These are the only areas I'll be grabbing problems from. So when you get a test or a quiz and there's a problem to be done, you know it's got to be one of these or one of these. I pretty much don't stray from the subjects when it comes to the big point problem. You know, I'm not trying to trick you. I'm leading you in the direction of how to prepare. So if you're saying, hey, there could be production lot size on this, write down some information that you know exactly where quickly to look to refresh your memory how to do production lot size. And that's how you prepare instead of memorizing production lot size formulas. All right, so there's the subjects. There's our schedule. I always start off each day, remind you of the schedule. And we left off on chapter 13 looking at this. Strong demand, weak demand. There was 3 decisions, small, medium, large. And just to review real quick, if we were doing the maxing max, how many different outcomes would you have to consider before you tell me which one's the very best? How many outcomes would you have to look at if you were doing maxing max and showing work? 3, because there's 3 decisions. And with maxing max, you'd be telling me decision 1's best outcome. If this is profit, 8. Decision 2's best outcome. If this represents profit, 14. Decision 3, 20. Then the next step of showing work is which one of those 3 possible outcomes is the best of the best. Maxing max, then you would say decision 3, large complex, 20. There's your work, right? How many outcomes would you have to consider to show work if you were doing what's it called? Maxi min? How many outcomes would you have to put to show work that you have to consider the best of it? How many will you show for work? 3, because there's 3 decisions. The reason I'm pointing this out is because a whole bunch of you did not get 100 on the in-class. The in-class assignment is designed to help keep your grade up. So I want to make sure you realize the process. That seems weird. What happened on the in-class, it seems like some of you from a couple of groups checked with the other group and did the exact same mistake. And so I need you to check maybe with a second group in another part of the room and not right near you, because there was like 6 of them with the exact same mistake. And I'm reviewing this so that you know what I'm expecting on the quiz. What for work? Show me the 3 outcomes you're going to consider if there's 3 decisions. The worst possible outcome for each decision if you're doing maxi min. Now, it is a coincidence they're right here under weak demand, which is pretty normal, but it doesn't always mean they'll be there. You still got to tell me, maxi min, the worst possible outcome for decision 1, 7, decision 2, 5, decision 3, -9. The recommendation or the selection would be whatever the best of those are. If this is profit, small, 7, right? Is that the best one? Yeah, right? Well, I want to make sure you understand what happens. Turn it around backwards. This is a cost table. You're the manager, owner of the business. When you're looking at this, you got to look at it from the point of view that this is your business. So what does cost mean to you? The lower, the better. Because as a business manager or a business owner, you want your cost as low as possible. I have an assignment to give to you, but I want you to walk past the camera so I can mark you late. I'm just giving you a hard time. I am going to mark you late. I'm not keeping up with that. Garrett, is that your name, Jacob?
Yeah.
Jacob? Steve?
Jacob, yeah.
Someone tell me it looked like he said yes to the So you come late, I get to embarrass you a little, no big deal.
It's okay.
All right. This is a cost table. Maxi Max. You look at it from the person who owns this business, who manages it. And if it's a cost table, the best to you would be the lowest number of possible outcomes. So let's pretend this is this is a cost, and we're doing Maxi Max. What you're looking for is not the largest number, the best possible outcome for each decision. Decision 1, the best outcome, cost table would be what? 7. Decision 2, the best outcome would be what if this is a cost table? 5. Now look at this carefully. Decision 3, which is large complex. If this is a cost table, do you understand what this represents? Yeah, the opposite. There'll be no cost. It's impossible to have a cost there. It's a negative. So it's like, I guess, profit. So this has to be if you're looking at if this is cost $20,000 a week, or cost -9, which means there's no cost, this has to be the best one as far as that decision is concerned. So now we selected this, this, and this. Maxi Max, cost, what would be the best outcome? Obviously the lowest number, because it's cost, so it wouldn't be 7, wouldn't be 5, but then -9. So you'd be recommending decision 3, large complex, -9. Everybody see what I expect will work on? These are so simple that, you probably started out thinking this, I don't know, thinking that it was more than what it is. That's how easy Maxi Max and Maxi Min is. They're just really easy. Maxi Min, I just want to make sure you get this. Cost table. Decision 1, what outcome are you looking at? Maxi Min, cost table. Decision 1, what's the outcome? No, yeah, sorry, it is 8. Just checking. Decision 2, 14. Decision 3, 20. Because you are selecting the worst possible outcome for each decision. But then, now you're going to make your recommendation. The best of the worst would be decision 1, 2, or 3 of those worst outcomes. The lowest, not the largest, the lowest, which is the 8, which is decision 1. This is a cost table, 8 is the best we could do as far as the worst outcomes for each decision if we're looking at it. Mini-max regret, also if it's a cost table, it's kind of the opposite. You look at the state of nature, you pick the best outcome, and you subtract everything else from it. Now, if this is a cost table, think about it. That's the best outcome, not that, like when this was a profit table. So this would be 8 minus 8, 0, 14 minus 8, or 8 minus 14. You can't get this wrong because you use absolute value, meaning drop the negative. So 8 minus 8, 0, 8 minus 14 is, what is that, 6? So you got 6, and 8 minus 20 is 12, 0, 6, 12. You do the other side. Right? Mini-max regret, then you find the maximum regret for each decision, so you're going this way. And then you give the recommendation of whichever one of those maximum regrets for each decision is the lowest. And you make the recommendation. I just want to make sure you understand the difference between profit and cost, because has anybody looked at the homework yet? I had it posted early. You did look at it. Did you notice the bottom table? The other classes, only one person so far has handed it in correctly, realizing it says cost. Everybody else's answers think that's a profit, and not realizing it's a cost. So your homework, I'm pretty sure that second problem's a cost table, so be aware of that when you do it. All right, now we're going to the new stuff. We got to get going. We got to learn something. Expected value. Expected value is really a much better way of doing decision analysis than using the Maxi Max or Maxi Min. But with expected value, you can only use it when you have probabilities with the state of nature. That's the advantage of expected value. So somewhere along the way, you're a manager. And this is, I want to tell you what life was like as a manager. Meeting after meeting after meeting, wasting time, having meetings. We had multiple locations, so we'd have to drive, more wasted time. Yeah, I remember the internet was just coming about, and nobody had video conferencing then. Meeting after meeting. And in those meetings, if we had a big decision to come up with, we would try to come up with probabilities of this possible state of nature and the probability of this one. We know there's a 100% chance that one of these are going to happen. So when you come up with probabilities, they have to add up to 100%. You will always be given those probabilities if this were a quiz or a homework. You'll be given. You don't have to go to meetings and come up with it. And let's pretend, I'm trying to remember now what percentage is. 18, slide 18 tells us. 80%, so the story's going to say there's an 80% chance of strong demand, 20% chance a week. So I'm going with 80%, 20%. There's our two states of nature. Let me go back to the numbers. Go ahead. You do expected value by just applying each of those percentages multiplied by the possible outcome for each decision and then add them. Let me show you. D1 has an 8 for strong, 80% chance of strong, 0.8 times 8. Plus, it has a 7 for weak with a 20% chance of weak, 0.2 times 7 equals. Add those up, somebody. Next, 0.8 times 14 for the second decision, plus 0.2 times 5 for the other demand on the second decision. Multiply, multiply, add them up. This is easy, right? That's 10, or that's 2, or that's 1. That's what I meant. 1. Well, what is this one? Nobody. What about this one? This is 6.4? 6.4? Nobody's doing this. Is that correct?
7.8.
No.
Yeah.
This one? This got to be 6.4, right?
6.4 plus 1.4.
6.4 plus 1.4 equals 7.8? Is that what you said, 7.8? You got me to the total. 8.8 times 14, that's, what is that, 10, 11? 11.2 plus 1 makes 12.2. We're almost there. Decision 3, same process. 0.8 times 20, what is that? 10.6? Nobody. That's 1.6? 16? Is that what I meant?
Yeah.
Okay, that's what I meant. Plus 0.2 times, and here we go, it's a negative 9. So we're going to end up subtracting this. That's 1.8. 1.8, so minus a 1.8. So 16 minus 1.8 would be 14.2. Does that sound right? Is this a profit or a cost table? Because we just calculated the expected value for each decision. Now we need to make a recommendation. Is this profit or cost? Profit? So are you, based on these expected values, are you recommending decision 1, 2, or 3? Can't hear you. 3. That's right. Profit, you want to select the highest one. The process, if this is a cost table, does not change. It's done the exact same way, but your recommendation would not be the 14.2. It would be the 7.8 if this is a cost table. Everybody see the difference? Let me repeat that. The expected value, whether it's a profit table or a cost table, is done exactly the same way. The percent chance of the state of nature times the possible outcome, and so on. But your selection as to what you're recommending has got to be based on the lowest if it's a cost table. But this is profit, so we went with the 14.2. You just calculated what's called, what is that? EV, expected value without PI. Expected value without perfect information. That's what we just found. That's what that 14.2 represents. Expected value without perfect information. Let me just start with expected value. I'll make sure. If I gave you any table and I gave you the percentage of chance for each state of nature, can you calculate each decision's expected value? Yes? Everybody understand how to do that? Okay, we're going to the last part now. This is called expected value of perfect information. Once you've gotten the expected value, that's the expected value without perfect information. I want to make sure we're all, I got to go back to this table, but I want to make sure you see, you visualize what I'm trying to get to here. We're going to slide 20 if you got your notes with you. The expected value of perfect information is the expected value with perfect information minus expected value without perfect information. That process we went through is that right there. That's what we're subtracting. We just have to come up with this now. And so write notes how to come up with this expected value with perfect information. Here's the notes. You find the best possible outcome for each state of nature. Let me repeat that. This is expected value with perfect information calculation. And you find the best possible outcome for each state of nature. And you multiply it by the corresponding percentages that you used when you did this exercise. So I'm going back to the numbers. I want to make sure you get this. Sorry, I know some of you are looking at that, but this is what you need to see. look at standard nature 1, which is a strong demand. Tell me this is the profit table, right? Tell me the best possible outcome you see. I can't hear you. Wait, is this it?
No.
Oh, guys, give me that look. Okay, here we go. Standard nature 1, strong demand, best possible outcome. 20. We got that right here. So 0.8 times 20. Look at what's happening. I have the cap off too long. Again, 0.8 times 20. We know this is going to be 16 plus 0.2 times best possible outcome. The second standard nature. 7. We got that right here, which is 1.4. So the expected value with perfect information is 16 plus 1.4 makes 17.4. This is with. This one's without. 17.4 minus 14.2. Not all at once. 3.2.
Yeah.
3.2. We just found right here the expected value that we would be willing to pay for additional information to get us closer to that. Let me repeat this. You ready? Your business is relying on getting a class, I think it's called a Class C3 commercial building permit for your business to get up and rolling. And you have to go to the township board to get this permit. And you don't know how they're going to vote. I'm consulting with a business right now. They're about to open up an axe throwing business. And they're in this exact situation. They have no idea if they're going to be able to get this permit. The building they want to use is not zoned for recreational axe throwing. All right, so they have to go do this special application and get this. They don't know how it's going to turn out. So, here's the thing. When you calculate something like this, this is basically telling you if you can get more information, because there'll be a benefit to get more information, you just calculate the most you'd be willing to ever pay for additional information. Because if you pay more than what you just calculated, you're wasting money, because the additional information will most likely only get you up to what's called the expected value with perfect information. Here is our expected value without perfect information. Everything we know right now, this is what we expect. But we're thinking about, we have this opportunity to bribe a township. No, let's not go there. I didn't mean it. We have this opportunity that someone who knows all the township trustees or council or whoever they are, to poll them to see what they're leaning toward voting on, whether to get this permit or not. But how much are we willing to pay for this additional information, and what's the advantage of having it? I can't think of an advantage in their case, other than they want to get remodeling right now. But they don't want to start spending money on doing all this remodeling to form these axe throwing lanes, and, unless they know they're getting the classification for the building to be able to do this, throw axes. And so they don't want to start building all this stuff and putting all this money into it. But if they had additional information, and they're willing to spend for that additional information, if they can find out much more confident as to how this vote's going to turn out, and they only had to pay, let's say this is in thousands, and they only had to pay $2,000 to get this information, and if this information they get is positive, they can start building and feel confident even though the vote hasn't taken place yet, then they should never pay more than what you just calculated the expected value of perfect information. That's the most you would ever want to pay for that additional information. Because if they got it, they can start, they're going to save money on rent, because they're paying rent right now, and they can't even get in there to start building, to start making all the remodeling and building these lanes with the targets and the fences on the side and all this other stuff they got to do. So they aren't going to be able to generate revenue until they get all that remodeling done, which is going to take like 2 months. So they're paying rent for 2 months because they're sitting. And right now, they're not doing anything because they don't know how it's going to turn out on the vote to get that classification to be able to throw axes in this work. Everybody get it? That's what you're calculating to do this. How much is the most you should be willing to pay if it can get you closer to knowing how the state of natures are going to turn out. This would be, they'll approve your application. This would be they do not approve it. And getting closer to knowing if you're going to approve or not could let you save money by getting things done right now instead of waiting. As an example. That's chapter 13. We're done. You ready for 10? You need a break? Oh, that's it. That was your break. What? Oh. What we calculated called the expected value of perfect information is the most you'd be willing to pay to get more information that could lead to a better outcome. That's the most you'd be willing to pay for more information that could lead you to a better outcome. All right. On the listed topics, I only listed these first 4. So you, as far as the quiz is concerned in the final exam, only these first 4 could be on it. And questions about those, but problems, only about those first 4. Questions and multiple choice of true and false, only about those first 4. And I'm only introducing you to each one of those 4. When you get into operations management, you know, I don't know what this professor's doing, but last semester's professor, or the semester before, will go in depth into inventory control. And so, whatever you do, don't say, oh, we learned that in management science. I remember the professor come up to me, well, you're teaching inventory? I'm just introducing you to it. You're going to go much more in depth in operations management. So, and I got it at the beginning, so by the time you take operations next semester, even if it's spring or fall, you're going to forget everything I taught you. So let's learn it, just learn it again in operations, but it's going to go more in depth. I'm just going to introduce you to these 4. We're starting with the first one. We're going to slide 21. I'm jumping to slide 21 because I want to start with the formula. I got it written as if it's in Excel, but I'll show you really, you know, it did have Excel. Go like this, 2 times demand times where, holding cost, and this equals Q. Q or Q star just means the quantity. Now, when is this formula used? When we want to know how many we should be ordering from wherever it is we get it, and whatever it is we get from whoever it is we get it, this determines how many we should be ordering based on the amount we sell, how much it costs us to have it in our inventory in the warehouse, how much it costs us to place orders when we do get orders. This formula is 2. It's just 2, always. D, here's the key word. It's not just demand, annual demand. Everybody hear that? Many of these problems will not give you demand annually. You've got to convert it annually. This business is open 52 weeks a year. They sell 1,000 products a week. D would be 52 weeks times 1,000. 52,000 then would be D. The annual demand. C sub O, ordering costs. How much it costs that business to put everything together to be able to place an order. C sub H, holding costs. Everything that's involved in order for inventory of that particular item to be in the warehouse and us having it there. There's an overhead cost. Matter of fact, if we go to slide, I'm going to find it here, the 4. The story starts out, this story on here, that you all read before you got here, I'm just refreshing your memory. Starts out, R&B Beverage is a distributor of beer, wine, soft drinks. They're a distributor. We have, I don't know who the distributors are around here. In the old days, it used to be called Ryan Distributing, Ryan Beer Distributing. Anybody heard of that? Nope. Not one person. They may not be around still. When I was in college, though, they gave us free food. What? Yeah. I was on the football club team. You guys still have football club, right? Or is it gone? You guys don't even know. Who am I talking to? Is there anybody in this room? I swear we're recording. Really, you guys don't know if you have football club anymore, or I know you still have a hockey club, right?
Generation isolation.
Yeah, right.
Yeah. Beverage distributing, ready? The main warehouse located in Columbus, Ohio. They supply nearly 1,000 retail stores with beverage products. So they have a pretty big list of clients that they deliver products to. By the way, a distributor is ordering in mass quantities, and then they distribute it to all of their customers in smaller quantities, putting them mixed together because they have so many different beverages to offer, for example. The beer inventory, which constitutes how much? About 40% of the company's inventory is approximately 50,000 cases. With the average cost of a case at $8, that means 50,000 times 8 is about $400,000 just in beer. Just the 40% of the inventory is the beer. Now we're going to talk about just one brand of beer. What is it called? Bud Beer. There's the #1 beer seller. And if this is like a real life problem, you're going, okay, think about all the different things they have in the warehouse. We used to call them SKUs. I don't know if you guys ever heard of SKU? SKUs? Okay, good. I'm getting some responses. Thank you. And many warehouses have tons of SKUs. Bud Beer would be one SKU. So we're saying, I used to work for this consulting firm, and I'd go to business. I'd say, hey, I'd be in the warehouse, and I'd go, hey, you're ordering, I can't remember, 4,000 cases of Bud Beer from the company. What made you decide to order 4,000? And they usually just say, that's what I was told. That's how we always done it. Da, 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 da. That's a very common thing. And now think about it. What I'm about to show you with just the Bud Beer, they could do this with every item in the warehouse, because if I start asking about any of those items, the answer is usually the same. That's how we always did it. That's how I was taught to order. That's why we order that many. That's very common in small and medium-sized businesses. When businesses get huge and they blow up, they use sophisticated software calculations to determine how much Bud Beer to order instead of 4,000 cases. There's a perfect amount to order because there's a relationship as to what it costs to have that beer in the warehouse and what it costs to put an order together. Let's talk about, I'm going to go to, let's start with demand. This is a perfect example. You said, I just got promoted to inventory manager of the whole warehouse. You know, I'm making real money now. And I got to manage people. Wait till you find out how awful that is. I got to manage people. And I'm going to see if we're ordering the right quantity of Bud Beer. So I'm going to go and look through all of the Bud Beer we've sold for the last, how many weeks? 10 weeks. And figure out how many cases we're going through here. And they seem fairly consistent. Matter of fact, it's averaging 2,000 cases a week. Is that right? 2,000 a week. And in the story somewhere it says they're open, no, not all, they're only open 5 days a week. 5 days a week. Hang on. Where's the story? Where is it at? 23. They're open 250 days a year. Don't look at the rest of that. We're not there yet. 250 days a year. Okay? I'm going to go back to, where's demand? Thank you. How'd you know that? Who said? How'd you know? Thank you. All right? So now they say, okay, 2,000 a week. When it says you're open, what was it, 200 days a year, or 260? 250. 250 days a year. You could say, well, yeah, there's all kinds of different ways you can calculate this, but if we divide this by 5, we can get our daily amount, multiply it times 250, and there would be the whole year. There's one example way of doing it. On that slide I gave there, how did they do it? I forgot. Let's think of it. I guess we will look at this. Was it 17? This way. This is where they calculated it. They said, hey, we're open 52 weeks a year. 5 days a week. That's 250 days. They probably have 2 weeks off, because it's really not 250, is it? They probably have 2 weeks off. We're going through 2,000 cases a week. So our annual demand, 104,000. We just found D. Right here. 104. Now this is where the points are at. This is a quiz problem. You're showing me the detailed work that you took 2,000 times 52 equals, and you're putting D equals. You're showing me this work. You've inserted a 104,000 right there. Again, all the points are, you're able to tell me which numbers go in which variable. And if there's some calculating to do, that you show the calculation. The only calculating that's usually always has on these problems is the demand, because it's usually not given to you as an annual demand. You got to convert it. and the holding cost, which is where we're heading here in just a second. Let's see, matter of fact, we're going there now, slide 8. Here is, now, I want to tell you my experience, how I had to come up with the holding cost in real life. What does this one say? Blah, blah, blah. It is all these things you're going to read on this slide and the next slide. I had to go in there and I'd say, okay, you just told me that you order 4,000 cases of Bud beer. Show me the process when it comes time. What makes you decide it's time to place an order? Oh, when I see that pile of cases I have a mark right there on the side of the bin. When it gets to that mark, I know it's time to order. That's how I believe it or not, that's a true answer I've heard before, just so you know. That's real, that's real. And then I start going, okay, now show me the process. Let's pretend it's at that mark. And they'll go, okay. Goes over to his or her desk, grabs the thing. I fill this out with the SKU number, how many, we always order 4,000, blah, blah, blah. Then what do? Take this, I put it in this envelope, I route it to business where they have to actually place the order. I'm letting them know this is time to order. All right, so I say, who is it you send it to? Who does the ordering there? I find the name, I go there. I start asking him or her, what do you do to place an order? Oh, I take all these things, put them together. I have to put together an order by typing it all out. I then have to fax that to each of the companies. It goes on and on. I say, what's the average amount of time to the person in the warehouse that you take filling that out? I say, I go to the office. What's the amount of time on average it takes for you to do your part, to place the order? Part of the ordering is when it comes in. So I go back to the warehouse. Okay, the order's been placed, hypothetically. The truck's backing in. Tell me what you do when the truck backs in. Oh, I go get so-and-so, and we take the forklift. I make sure everything's clear, that he or she takes the forklift, picks that up, brings it out, gets it over there in that bin where that mark was. How long does that usually take? That is the kind of way in real life, in real business, where you got to come up with this holding cost. All of these questions. And then I have to go into their financials and figure out how much money is wrapped up in inventory. What is the value of everything that's in there on average? So I got to look at month after month after month, try to find an average of what's in there. And then I have to look up how much they usually pay for electricity, how much they pay for, if something has to stay cold, they have refrigerated warehouses. I got to look at how much it costs to keep that all refrigerated and so on. All of this stuff. And if their own money is in that inventory, that they don't have a loan that's paying for that inventory, I got to say, well, what would they do with that money, and what would they make on it if it wasn't sitting in inventory? And I figure out what percent they could invest it with no risk. You know, right now, maybe they could make 2% on it. Divided by 12, I can see how much a month, called an opportunity cost, because their money's wrapped up in the inventory. If they do have a loan, then you got to go and figure out what percent they're getting charged on that loan, and figure out what that cost is on a monthly basis and so on. These are all the things. Cost of capital is that opportunity cost I just described, or the loan. Then the things like, where's the rest of the stuff here? Insurance, yeah, all companies have their inventory insured in case of a fire. Taxes, breakage. What's up? Pilferage. What's pilferage? Stealing. That's right. Your warehouse employees, damn intern, stole the case of beer. I know it. I didn't get the camera. We didn't have a camera. Yeah. So you got that warehouse overhead. So you put this all together and you figure out what percent of the cost of one item, or the average percent of the cost of all the items, goes towards paying all those things of having something in inventory. In this case, and you'll always be given that for this class, it will say something like, the annual holding rate's 25%. When you're given that, you need to take the 25% and multiply it times the cost of whatever item we're calculating this for. Bud beer. What does it cost for one case of Bud beer? See it there? The cost of one case is $8. We established, which would be given to you at 25% holding cost. Our holding cost, $2. We just found C sub H, 2. Right there, that's a 2. And the work we're showing is 0.25 times 8 equals 2. C sub H calculation. The demand and the holding cost are about the two only calculations, because the ordering cost, which we're about to talk about, is almost always given to you also. There's nothing to calculate. In real life, I do have to calculate the ordering cost. Again, postage for putting the order together and mailing it, if you had to mail it. Telephone part, you're using the phone system, which we're paying every month on, for placing the order for that Bud beer. What percent of that phone bill is just for placing an order? Transportation, invoice verification, receiving, checking everything on the invoice, making sure we're getting the goods that we ordered and the ones we're about to pay for. I used to work for Chevrolet, by the way. And Chevrolet, this was all General Motors, it's a big deal. When they're receiving parts for manufacturing process, they have to check every item on that list. And I used to work in accounting at Chevrolet, and that list would get sent to me from whatever part of the country that got shipped to a Chevrolet plant. They're all over. Then I'd have to take that list with all the check marks and compare it to the invoice to make sure we're not paying for something or getting charged for something that never got dropped off. It was an awful job. Chevrolet's so huge, I spent 8 hours a day matching those up. That was my full job, passing it on to the next person who then does the next step to verify we're going to pay this bill. They're so huge that a full-time job is just matching up the check marks to the invoices. I didn't stay long. You get more easy and stuff like that. And that's how life is. That's the kind of job. It was a good experience. Got my job. It was my first job out of college. Got some experience with a big corporation. And led me to the next job. So the ordering costs, these are the kind of things you're looking at. And it will be given to you. And let's say in this story, I'm trying to remember what's the ordering cost here. There's postage and receiving cost, 17, ordering. So we've estimated the ordering cost to be $32 per order. Here's my C sub O, 32. I have every number now. Now, there's 3 things from this particular EOQ model that is going to be on that list of topics. There's what's called, obviously, the optimal quantity, which is that one. Total cost, which we're going to talk about in a minute. And then reorder point. These are basically the only 3 areas that if I were to put a problem, now I'm not talking about true, false, or multiple choice, a problem on the quiz, it would be one of these 3 if this subject is about the problem. So it'd be all these 3, or 2 of these 3, or 1 of these 3. But if you're saying, I do want to study this a little bit, optimal quantity, total cost, reorder point. We're not doing the cycles. There's a whole bunch of other ones in this chapter for this one. Those are the only 3 you need to focus on, okay? So now, we're about to find the optimal quantity. But before we do that, I want you to see the total cost formula, which is on slide 18. Slide 18 as total cost is the exact same numbers. It's just set up differently. Right here. 1/2 times the quantity that we're about to calculate, Q. Right here. That's going there. The holding cost, we calculated out to be 2. Plus annual demand, we calculated it at 104,000. Over that quantity again. That's what we're about to calculate here at Q. I bet somebody's already calculated this too. Anybody? Don't tell me what it is, just tell me if you calculated it. For the record, no one raised their hand. Because I don't think the camera can see all of it. C sub O is the ordering cost. Every number you used in here is already used. You now plug into this formula for total cost. Now, the reason I'm bringing this up this way is because when I worked for that consulting firm, this was one of the, if I thought they were losing money based on inventory control, this was my favorite part. At the end of my week, I had to present to the president of the company or the board my findings. This was always my favorite part because I'd always put, now look, I put all the numbers in. Here they are, here's the $2, 104. I left Q blank. I left Q as Q. Got it? $32 ordering cost. And I used algebra to get it to here. And then I say, you are currently ordering 4,000 cases of Bud beer every time you order. So let's put a 4,000 there and see what it equals. This is what I say to the president of the company, the board. And I say, now, I'm calculating you should only be ordering how many? No one even calculated after I gave you a hard time.
1,824.
Thank you. 1,820. 1,824.2. Okay, I just needed to, I always want to make sure you're rounding perfect. 1,824 is the amount you should be ordering, not 4,000. By ordering 4,000 at a time, your holding cost is much larger than it should be, and your ordering cost, because you're ordering so few times, is much lower. And that's what most companies are doing. Either their ordering cost is out of whack compared to the holding cost, or their holding cost is out of whack compared to the ordering cost. If they're ordering 4,000, where's my total cost? 4,000, their holding cost, this part, where's the holding? This part right here is way out of whack. Because they ordered too many. They're not ordering enough times. This EOQ, what you're really calculating is, how do we get that ordering cost and that holding cost as close as possible? Because when we get it to that, however many we have to order to get those two costs in balance, that's the lowest you can get the total cost at any time. If you don't have those two, the holding cost, ordering cost, and balance, then you're wasting money either on the holding or the ordering. So that's what this calculation does. It says, if you want the holding cost and the ordering cost to be in balance, so you're not throwing money out the window, and you're increasing your profit, stop ordering 4,000, start ordering 1,824. Total cost. Did anybody plug in 4,000 for Q and get a cost? It'd be $4,100 or something? Not all at once. Take 3,328,000 divided by 4,000, and then add it to 4,000. Tell me what you get.
4,832.
$4,832. Is that what you're saying? Does that sound right to me? It sounds a little high, maybe. Is this anybody else? No confirmation.
Yeah, 4832.
4832? 44. Okay. So I say this is the best. When inventory is their problem, I love the look on their face at the end of the week. And I got done showing them all the things I found out, and we're on inventory. And I say, now, for just this one item, Bud Beer, you're spending $4,832 a year for holding it in inventory and placing orders to get more. If you change this one procedure and stop ordering 4,000 and order 1,824, so here, hang on, where is it? Right here? Your total cost will be $3,649. 3,649, is that what it is? And difference, 9, 10, 11, 12. So we got 3 here.
1,700.
Huh?
Like 1,011.
Say it again.
1,183.
1,182. Okay. $1,182 savings. And someone will go, well, that's only a $1,182 savings. But then I say, how many SKUs do you have? Oh, we have 950 SKUs. That's one SKU. If you apply this to 900 of them, and you're saving maybe an average of 500 on each one, there's where all the money's being wasted. All because everybody is ordering things the way they've been taught, or the way they've been told. And nobody is using math to calculate how many should be ordered instead. And money's being thrown out the window in holding costs. It's the number one mistake with small and medium-sized businesses until they get somebody that comes out of college and says, hey, you got an opening in your business, I'll come work there. And you recognize, this is how it happened to me, you mean our employees are ordering things just winging it? There's no one's telling them, hey, this is how you calculate it? And it just saves the company a ton of money. And you will get the promotion. You will get the big raises because you are bringing in something that will save the company money. Once you get into management, you have those advantages. And you can bring stuff in like that. Go ahead.
So when there's like a homework in your quizzes, you want us to round it with a
You can, I always say round it any way you do, you feel like it, as long as it's correct rounding. So wherever it is you round, I'm looking at the next digit to make sure you did it correctly. So if you want to go 0 digits to the right of the decimal or 5 digits to the right decimal, I take it all. I just want correct rounding.
Why do you round the decimal? Like, okay, so we have a decimal in point 2a, right? And I know that you round down when it's under.
What did I do? I went up?
5, right?
I didn't mean to go up. Oh, wait, what are you talking about? Where are you
I'm
at?
asking a question, just on the inventory.
There though.
Yeah. I understand. I'm asking, so isn't it better to have that one case of beer so that you can sell more beer than to round down to
Here,
the
well,
store?
now we're going to the reorder point. Because he's saying, but you're saying round up, make this 1825, right?
Right.
Right. You can. You know, some people do that. But for math reasons, I did appropriate rounding, which is fine. But what he's getting at is, knowing exactly how many you're going to order is the key to figuring out the reorder point and how long it takes for the order to arrive. Now, let me make sure you heard that, because this is a term you're going to see on your quiz for sure called lead time. Lead time. All right? How many Bud beer cases on average did we sell in a week? Does anybody remember? 2,000. 104,000 a year, 2,000 a week, right? So here's my 2,000. We read the story, and the supplier that manufactures Bud beer guarantees, you got by the lead time, hey, the lead time, I don't know the slide number. Hang on, 23. And we're told, blah, blah, that Bud Beer, the manufacturer, guarantees a 2-day delivery. 2-day delivery. Your reorder point is always however much product you go through in the time it takes to get the order here from when you place it. In this case, 2 days. So we need to figure out how many cases do we go through in 2 days. Now, what I'm teaching you by setting your reorder point based on the lead time is what's called just-in-time, J-I-T, just-in-time inventory management. It's a big deal. If you have any, I have parents that worked at General Motors, you'll hear the just-in-time inventory complaints all the time. Anybody have parents that worked at General Motors or anything? Okay, you've ever heard the word just-in-time at all?
I've heard of it, but it wasn't used in the context of work.
What happens sometimes when you have a just-in-time inventory system, you're gonna, if you ask anybody that works at a General Motors plant, they'll say, if the supplier doesn't get it there in the lead time that they promised, the whole line has to shut down. Because we'll end up running out. That's the risk with just-in-time inventory. But the benefit, here's the benefit. By making your reorder point exactly at the amount that you'll go through while you're waiting for it to arrive, because the plan is that you're selling or using the very last item the moment the truck is backing up to the dock to replenish that. The whole purpose for this system is to have less money wrapped up in inventory. It frees money up to expand your business, give raises to employees, invest in other areas. It's all about having the least amount of money held up in inventory that you can't use now for any other part of your business because you've got to keep having that inventory. And so the just-in-time says, let's figure out how to keep the money wrapped up in inventory as low as possible. And it's all based on that lead time. We go through 2,000 cases a week. They're open 5 days a week. Is that what it says here?
Yep.
Whatever it says. So that's 250 weeks divided into 104, that's 416 cases a day, excuse me, 250 days, that's right, the story said that. So per day, 416 cases, the lead time's 2 days, 2 times 416, when Bud beer, and now everything's computerized, so every time a Bud beer gets loaded onto a truck that we're taking to one of our customers, we check, it came out of the inventory, it got scanned. The inventory keeps account. And the moment that inventory gets maybe at 834, 833, really close to 832, at the end of the day, whoever's the manager of the warehouse runs an inventory sheet. And everything on that sheet is telling you every item that's about to need to be reordered or is at reorder. And that's how these systems work. Let me repeat that now. 1,824 Bud beer cases just arrived. We've just put them in the bin, 1,824. 10 went out to one of our customers, another 10, another 20. We're down to 850. We're not paying attention because we rely on the system. The next day comes, the system just recognized that we're at 832. That day comes to an end, it's there, we gotta get some Bud beer, we're down to 832. That means we're probably gonna go through every one of those in the next 2 days, so we gotta get that order in, so we arrive before we run out. That's the risk involved, and that may be the advantage of getting the extra case, because the cost of running out could be high. You never wanna say to a customer, I don't have it, I'm sorry. They'll go somewhere else and get it, they don't have time to wait for you to get it in, right? So there is a risk. So some managers say, I know it's gonna have a little more money in inventory, but I'm gonna raise my reorder point just a little bit so I can order a little sooner as a little bit of insurance so I don't run out. And that's usually why some, companies will round up to have that little bit of insurance just in case something happens. Well, snow, what do you mean? You told me 2 days. Snow never stops my mail, get my beer. I mean, what the heck? How do we feel? We got lead time, so we have the reorder point, we've got total cost, and we got the optimal quantity, right?
I have a theoretical question.
A theoretical.
Yeah.
Go ahead.
So what happens when the cost for holding it is virtually zero? And I know you have to keep the order cost in balance. So how does that work?
I've never seen a holding cost near zero. And then whoever's calculating the order cost or the holding cost is not taking everything into consideration. Because even if that 2 cases of beer aren't even in a warehouse and it's on the floor, that's still a holding cost because that floor that part of the floor could be used for something else that generates money for you.
Okay.
So it's a matter of if this were a real life, if someone, does that mean? If someone's working somewhere where they go, you know, I want to calculate this. Well, why didn't you tell me? If somebody really wants to calculate a holding cost where they work, start doing a internet search as to everything you've got to take into consideration to get a true holding cost, which includes, you got to go to your company's electric bill. You go, you're paying $500 a month. Okay, how much electricity is going to having this beer right here? Well, in a warehouse, you get the full square footage of the warehouse, and you figure out what percent of that square footage is Bud beer. And then you multiply that percent times the total cost to have electricity in the warehouse. Same with if it's air conditioning. You get the whole air conditioning for that warehouse, you multiply times the percent that Bud beer is taking up of the warehouse. You see all the things I'm talking about? The part of the phone, because you have to place orders to get the order in. Go ahead.
Okay, so this like piggybacks off that. At what point does that all become redundant? So.
It doesn't come redundant. Here's what happens. Well, I mean, each product you need, yeah, once you did an ordering cost, it's probably the same for every SKU. Is that what you mean? Like that?
Well, sorry, okay, so you a business where you want to sell beer.
Yeah.
Your opportunity cost to sell something else is zero because you don't want to sell that stuff. So
It doesn't mean you have to sell another beer. It could be any item that generates profit. Any item that could generate profit. If you find a retailer, let's say a big retailer, they can tell you really what they're making off every square foot of the store, like a Target. You go to the home office of Target, they'll tell you exactly the amount of money they're making off every square foot, and they take that into consideration when they're putting their aisles together and who gets the end. Manufacturers sometimes will pay you to just have the end of an aisle so that people are walking right by it every time. I mean, it's really weird how it works.
Yeah, I was just going to say the same thing. It could just show that you should either outsource your warehouse or have a smaller warehouse.
Yeah, that's possible too. So, and most companies don't have all their inventory paid for. They usually have a loan they're making payments on, so that's definitely a cost because you're paying interest on it. That is. For these problems for this classic, it's all about you not necessarily, understanding exactly how all these numbers are come up with. It's how to use them, what you have, how to use them. Any accounting measures? Okay, you are the ones who most likely have to come up with all the numbers if your company starts going towards using decision analysis like this. Okay. In my case, it was always the accounting department had to do all that research. What's it cost to place an order, and all the details. All right, do we have enough time for one more? Are we good? What do we got? Give me that time. What are you talking about? We're going to slide. Yeah, let me just look here. Blah, 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 blah. Right here. There we go. So that first one was EOQ, right? You got 4 of them you're learning. And some students, the hardest thing is when they read a problem is going, which one of these is that problem? How do they identify which one to use? That's the part you might study not necessarily memorizing these, but recognizing which one to use based on the story. Here's my hint for this one. This, called production lot size model, is only used when the story's talking about, they're trying to determine the optimal amount to make, called a production run. How many they should make in a run. It's a manufacturing, how many they should manufacture. It's the only one of the 4 models that's trying to find the optimal amount that should be made. Not how many should be ordered from our supplier, not how many we should order if we get price discounts, that one's coming. This one's how many we should make. It's the only one. So if the question's about they manufacture widgets, whatever widgets, and they're trying to determine how many they should manufacture in a run before they shut the machine down and set it up to make something else. Because in real life, companies pay a lot of money for these machines, and they want it to be busy as much as possible. And when that machine's not doing anything, they still are paying the loan, the $1 million loan it took to get that machine. So they're trying to find other products you can make during the downtime to get a return on the investment. So here's the deal. All right? The formula to figure out the optimal amount that should be made is very similar to the formula for the optimal amount that should be ordered. The difference is, let me think here, is 2 times D times C sub O over 1 minus, I got a number here, D over P, parentheses, times the holding cost, or is that divided? Square root. Don't forget, if I have S, Q, R, T, that's like this, that's still square root, and I'm just using Excel. That's all. It means the same thing. I want to check this formula. We're going to slide 36. Let me just make sure I have the right formula. Yes. Here's the difference. You know what this is. This D, annual demand. That D right there, same thing, annual demand. C sub O is not ordering cost when it comes to production. Instead, it's setup cost. So it's still C sub O, but it does not represent cost of ordering. It's cost of setting up to get the machine prepared to do a run. It's called the setup cost, very common. C sub H, same thing, there's a holding cost because you make a whole bunch of them and you put them in the warehouse for inventory and then you hold them, and as they go out, you start to get close to running out, you do another run so you don't run out. Here's the odd one that you haven't seen before. P represents the production capacity. If that machine were running the whole time we have employees here working and never had a downtime, how many could it make? That's what P is. How many could it make in a whole year? I said a whole year because that D is a whole year, but this actually is the only spot where you don't have to use a whole year. As long as the D and P are the exact same interval of time, it calculates the same little ratio. You know, if this is a year and that's a year, whatever that equals. But if you want to make that 1 month, as long as that's 1 month, you'll get the same ratio. That's a day and that's a day, the same ratio. But only that part right there is where you don't have to convert to a year. So now, you ready? We would start reading the story and we're looking for what is the setup cost? What's the demand? And is it given to us annually? Do we have to convert it? Where do we go? We're going to slide 96. Says, in this case, they make soap. They're going to focus on how many bars of soap they're going to make. And it says, beauty bar soap is produced on a production line that has an annual capacity of 60,000. Which variable did we just read and get the information for? P. There's your P. Annual capacity. If that machine were making, what was it called? Beauty bar soap, the whole time we're there running the machine, we would end up making 60,000 cases, I forgot the word cases, of soap in a year. The annual demand is estimated to be 26,000 cases. Which variable did we just find? D. And if we want to get that D over P, 26,000 over 60,000. There's that part right there. Order of operations, you must take D divided by P before you subtract from 1, or you will not even come close to the right answer. Let me say that again. You must take your demand divided by your production capacity before subtracting it from 1. This is a very common mistake, order of operations. Anybody else has to sign in other than the front row here? Is everyone else but this front row? Okay. So there's that. The cleaning, preparation, set up the production line to have that machine start making cases of soap, $135. What variable did we just describe? C sub O, your setup cost. There it is. This is just like a problem you're going to see in your quiz if this one's on your quiz production lot size. You're going to be given the production capacity, the demand, the setup cost. The manufacturing cost per case is $4.50. The annual holding percentage rate that was calculated is 24%. So we take 24% of the cost of making one case of soap, $4.50. $1.08 is which variable did we just find? C sub H. So we have our C sub O, setup cost. We have our C sub H, which is our holding cost. We have our annual demand. We have our annual production capacity. We can calculate now this whole thing. So it would be 2 times, is that 26? 2 times 26,000 times 135, is that what it says? 135 divided by 1 minus 26,000 over 60,000, is that right? Parentheses around this, so we know we got to do this, then subtract the 1, times our holding cost of $1.08. And don't forget to, last but not least, after you do all that math, square root. You do all that, and I want to give you an example, so we've got plenty of time. I used to call, when I worked for that consulting firm, I went to a lot of manufacturing companies around, most of the companies I worked with were east of the Mississippi, from the Mississippi to the East Coast, in that part of the United States. I'd fly out Sunday night, fly back either late Friday night or Saturday morning, because I'm at companies going through all their stuff, trying to pinpoint where they're not making enough profit, or where they're possibly losing money or wasting money. And the reason I bring this up is because, I forgot why I'm bringing it up. I'm sure I had a reason. I do want to point out one thing. Some places will not use a holding rate, and some of your problems in the back of the chapter will not use a holding rate. They'll literally give you the holding cost already calculated. So be careful. The story says, and the holding cost is $1.08. Say to yourself, wait a minute, what's the holding rate? They're not giving it to you. They went straight to the problems giving you the holding cost as a number instead of a rate. The majority, though, will give you a rate, then you got to find the cost of one item and get that holding cost. Go ahead.
Is your holding cost always going to be per case?
Is there a holding cost per case? Always. Always a holding cost. Even if because you have to get that off the truck that came here, and you have to put it somewhere. If it's, let's say you have a retail also, even if it's out there, I think this is what you asked, isn't it? Or what you asked. Even if it went out there on the floor, there's still a holding cost involved.
I think he was asking if it's always by case.
Yeah.
Oh. It's always by one item of whatever is being made. In this case, because the whole story is a case of soap, we have to assume that the rate would be times one case of soap. So whatever one item is that's described in the story. One case of beer in the other story. Okay? So it's one item in its description, not one bar of soap. The whole story is talking about cases, so we go with one case of soap. Thank you for clarifying that. We do all this calculating. Is it done for us? And what do we get? 3,387 cases. Now I just remember. In real life, I would always go to whoever's running that machine, and I would say, hey, how many are you making before you shut this down? How many different items does this machine make? They'll say, oh, 3 different items. Okay, how many items do you make of what you're making right now till you shut it down to reset it up to make one of the other items? And they'll say, oh, I make 3,000 cases of bars of soap. And this is just like the cases of beer. I'll say, well, what made you decide to make 3,000 before you shut it down to make the other price? Well, that's how I was trained. The person before me always made 3,000. That's almost always the answer. It's always, this is how I was told. This is how I was trained. This is how we always do it. And so that's why we make it 3,000. So then in my presentation, I'd say, let's calculate how many did I say? 3,000? Let's say they're making 8,000. I'd say they're making 8,000 cases of soap right now before they shut that down and make something else. My calculations, based on the holding cost and based on what it costs to set it up to make something, they should be making 3,387 cases. Stop right then make something else. 3,387, because again, your total cost formula, which by the way, it's slide 18. Wait. Sorry, slide 85. There it is. Your total cost formula for production lot size is slightly different than it is for the EOQ, because you got that P involved. But the concept's the same. You still want to get your holding cost and your ordering cost in balance, because when they're not in balance, you're wasting money. Either too much on the holding or too much on the ordering side. One or the other. So to get total cost for production lot size, 1/2 times 1 minus D over P. You already did 1 minus D over P right here, so you'll get that number. Multiply times Q, the optimal quantity we just calculated, times that holding cost, $1.08, plus the annual demand over the optimal quantity times the setup cost. I would fill in all these numbers but that Q, just like I did with the other one. And I would say, okay, you're ordering, or you're making, I can't remember, 8,000 I said? 8,000, let's put in 8,000 there, and let's get your total cost now for the year, making that one item, cases of bar or soap. And I say, now let's insert how many you should be making, which was what, 3,000 something?
3,387.
Was it slide 36? 8? No, not 8. Oh, thank you. All right, 3,387 instead of 8,000 is how many you should be making before you shut that machine down. And by inserting 3,387 for Q, right here and right there, if you take 8,000 and compare it to this 3,387, there's going to be a significant savings. Instead of spending whatever they're spending, 4,000 something, you can spend $2,072 a year on making that item. You'll save $2,000 every year. And again, they'll go, well, 2,000 is not a lot. I say, well, how many different machines do you have? We have 12 different manufacturing machines. How many different items are being made on those 12 machines? There's like 3 different ones on each one. That's 36 items. This is just one item. Do this for all 36. Now you'll see the savings. And that's the point. So for optimal lot size, you've got to be ready to be able to give me the total cost and the optimal production run, the amount they should make, the optimal amount they should make. And I want you to also be prepared that the story may say, since they're currently making 8,000 every time, calculate their total cost the way they're doing it now, then calculate total cost based on how many you calculated they should be making instead of 8,000, and calculate how much they'll save on just that one item. And that would be a problem on a quiz. Everybody hear that? Let me say it again. You ready? On a quiz, it will say, calculate the optimal order of production lot run for this manufacturing company, and you'll hear who goes through 26 a year. The machine we're left on, it can make 60,000, $135 to set it up, $1.08 holding cost, right? But they currently make 8,000. So the problem will say, one question will say, calculate the optimal quantity. The next question will say, calculate the total cost. Next question will say, now calculate the total cost with their current production run of making 8,000 every time instead of what you calculated. And calculate how much they'll save by doing it with your recommendation instead of the way they do it now. You're just doing total cost again with the number 8,000 on there. And whatever you get for total cost, you subtract it from total cost with the optimal quantity that you calculated. And the difference is how much they'll save. I want to make sure you get that. Worst scenario is, if you really feel like you didn't get it, I mean, I don't want you to rely on the video, but at least the video is there for you to go, I didn't get that very last part. Go back. And I'm being told you can even slow the video down, because I know I talk fast. So, slow it down. And catch that last little part, because I want to make sure you get it. You're comparing how much they would save if they just changed the policy of how many they make before they shut the machine down to make something else. Go ahead.
Are you saying you put 8,000 in the total cost equation?
Right there and there, instead of the optimal amount, put an 8,000 there, 8,000 there, and you'll come up with how much they're spending now because they're doing 8,000 at a time instead of doing 3,887. You subtract the two total goals, and that's how much they're going to save. It'll probably come out to a couple $1,000, I guess.
The optimal lot size, that's Q.
That's Q in this case. Q is always either how many they're making now, or however many, or how many you just calculated would be the optimal amount, or it represents different things based on what you're talking about, but Q is always the quantity.
Production quantity.
Production quantity in this one that they should make. And the previous ones, the quantity of how many we should be ordering. All right, you're